Welcome back to the channel. Today we're going to be taking a look at Log4j. Log4j is a popular logging library for Java created in 2001. The logging library's main purpose is to provide developers with a way to change the format and verbosity of logging through configuration files versus code. If you have written a program or used that program, chances are the output presented to the user is just print statements. When there is an issue, more print statements are added to the code around the problem area of the program. When the issue is fixed, the print statements may be commented out or just left in. What a logging library does is, instead of using print statements, the developer just uses a wrapper around the logging class or object. So instead of using print line here, the code will look like this, and you can see logging info, application started, logging. So it's basically logging each statement or each sequence. Then the application has a configuration file which says what log levels, info, warn, debug, and etc. to display. This way, when there's a problem with the application, the developer can enable debug mode and instantly check out those messages. Here, let's get started. All right, after we've launched the machine, we went to the IP provided to us. We can see this UniFi network here. Looks like we're going to be taking a look at this software with the Log4j vulnerability. We'll start an Nmap, see what's going on, what services, ports are open here. Here's the results, and the question for task 1 is, what are the first 4 open ports? So let's go ahead and see. Actually save this to a text file .txt instead of just running it normally. This way it can be brought up later if need be. Here we can see the Nmap SVSC 08T4 followed by P, which is all open ports, the V for version, O for operating system, A for aggressive, and SC service script, check scripts running as well. Moving on, I scrolled a little bit too far down on this Nmap scan, but that's okay. Simultaneously, we're going to run GoBuster just to check out any directories there, make our jobs and our lives easier moving throughout this machine. We'll implement the word list from user share word list, dirbuster. So it'll be GoBuster command followed by U for URL. We'll implement the URL followed by W for word list, and then the directory that the word list is in. Sometimes it's faster to type it in, sometimes it doesn't work properly, and you have to manually go into the files and find the word list you're looking for. We'll paste in the user share word list, dirbuster, and looks like we're going to reuse the directory list 2.3 medium.txt. Alright, not found. Probably going to have to actually install GoBuster. Yes, we are. So we'll do apt install GoBuster, and here you can see us actually downloading and updating the file or the software. From there, let's run the command again, and it should actually work with no problem. All right, here you can see it's actually beginning to take a look at some of the directories. This can run for a long time. So we're going to just keep looking at the questions and moving through the room. We'll answer the first 4 open ports here. You can see 20. All right, task 2 here. What is the title of the software that is running on port 8843 or 8443? We already went over that. That would be the UniFi network. Task 3, what is the version of the software that's running? It says it right here on the web page or the front page, 6.4.54. What is the CVE for the identified vulnerability? All right, so this is where it actually gets a little bit fun. We can use multiple methods here. We can use Google dorking, we can use Metasploit, we can use exploit DB. Matter of fact, we're going to use them all. So we'll begin with opening the terminal, and we'll check the search exploit here, followed by the program name and the version. No results, no problem. We can keep messing with this, keep trying to see if we can catch any CVEs associated with this version. Looks like we were able to find 2, a cross-site request forgery and an XXL for video default here. Not quite sure what that is. If you do know, please comment. Anyway, moving forward here, we're going to go to exploit DB and see if we can find any associated CVEs this way. Type in UniFi network, of course. We get 1,000 results. Then we try again, we get 0. So sometimes these things are really finicky with the names. Practice makes perfect. Let's launch MSF. We'll use the command MSF console. Here we get a beautiful heart and the ability to start using the software here. So we're going to go ahead and search for exploits for Unified Network 6. Nothing available. All right. As I mentioned previously, the names can be quite finicky. As you can see, removing the network aspect from the name here actually provided us with a lot more results. We can see 7 total associated CVEs here. And one that sticks out to us in particular would be 5. And this is a Unified Remote RCE. Very good. Let's go ahead and see if we can find some more information about this one or find some other CVEs that may help us obtain a reverse shell and or answer the question. Now the beauty of this is that in a constructed environment such as a lab, it provides hints and it's telling us to look for 2021. So we're going to go ahead and do that. Jumping back to the other web page here with exploit DB, we are able to get a little bit more information as far as release dates, different versions, different types and platforms, and etc. In the interest of time, none of these are going to provide us the answer, so we're just going to Google dork and find it that way. We'll go to Google here, and we'll pretty much use the same search parameters that we've been using. We have many different options here. We'll go on GitHub here, this Log4j UniFi. And we find the 2021 version that we're looking for here. And it's going to provide us with remote RCE. It also provides us with installation. It also provides installation descriptions, as well as a description on how to install it via Docker. We'll answer the question to task 4 here with the identified vulnerability here. Copy paste is a very nice feature. Let's check the blog post here provided by IPSec and Kim Crawley. Shout out to them for providing learning opportunities and putting all their time and efforts into making a system that's actually functionable and able to provide such quality. But anyway, moving forward, we'll open up the note here and we'll just kind of go along with it. Basically, what we're going to do here now is launch Burp Suite, and we're going to get our get post requests from the server after, of course, we've gotten some information. And then from there, we are going to take a look at the data that's being sent back. All right, we're going to get started here with these post and get requests, and all right, let's take a look at this post request here. The exploitation section of the previously mentioned article mentions we have input our payload and the remember parameter. So basically, we're going to catch the post request, and we'll be sending it to the repeater so that we can manipulate the data here at the bottom. So here we get back the internal server error after sending the request, and we can indeed see the application is vulnerable here. So now we're going to proceed to starting a TCP dump on port 389, which will monitor the network traffic, and it's the default port for LDAP, so it works out perfectly. Here we'll open the terminal. If you don't have root privilege, you'll need sudo. It didn't actually work, so we're going to open another terminal and just use sudo instead of relying on the default terminal that should have opened up with admin privileges. We've actually scrolled down a little bit, and as well as checked out some other notes on this box. Here we can see the open terminal, and we've been able to successfully start the TCP dump on the IP. Here we can get a response from the server, and at this point, the TCP dump is showing the connection being received. This provides the application is indeed vulnerable since it's trying to connect back to us on 389. From now on, or from the next point, we'll have to install OpenJDK and Maven on our system in order to build a payload that we can send to the server and get a remote RCE. So let's go ahead and install and update Java and all that fun. All right. Sudo apt update. We'll just update the Kali distribution here. Now, let's install this OpenJDK. Sudo apt install JDK 11. Here we can see it starts to download. This may take some time. It's a good time to go get coffee or whatever you'd like to do. Here we're brought to the configuration page after installation, and it's going to ask us to restart the services. So let's go ahead and do that now. All right, so we've successfully installed JDK 11. Let's go ahead and grab the GitHub repository. So we'll use the command git clone followed by the URL. For some odd reason, it's asking us for credentials. I do find that when it actually asks you for credentials and you're trying to download a GitHub repository, for me, it's ended up being the incorrect format, or I typed it in the wrong way. So feel free to try, like, I don't know, 1,000 times until it downloads the GitHub repository correctly without asking you for the credentials. As you can see, we've been able to get Maven. With no problem, but we are still struggling a little bit here with this git clone. Boom, boom, boom. Fast forward. In the interest of time, we installed it, and now, let's see here. All right, so we're now going to clone the repository and build the package using Maven. This is going to create a jar file in the rogue JNDI target directory called rogue JNDI, and we can construct our payload to pass in the rogue JNDI 1.1.jar application. To use the rogue JNDI server, we'll have to construct and pass it a payload, which will be responsible for giving us a shell in the affected system. We will be using base 64 encoding, and we'll do that to prevent any encoding issues. Here we can see the command here is provided to us. Basically, we're going to call bash and set the reverse listener and put our IP address as well as port. Very simple payload here. All right, so to use the JNDI server, we call the payload here, which is echo bash bash, followed by dev TCP, our IP, and port of choice. Looking at the notes here for this walkthrough, we're using port 4444 to receive the shell after the payload has been created. Start rogue JNDI application while passing the payload as part of the command option and your ton0 IP address to the hostname option. For example, jar target rogue, which is application, command, bash, echo, Uranus, okay. All right, we start our little server here. Okay, so after using the command java jar rogue JNDI, picked up Java options here, starting HTTP server, port 8000, starting the LDAP server, mapping LDAP. Let's take a look at the notes. Now that the server is listening locally in port 389, let's open another terminal and start a netcat listener to capture a reverse shell on port 4444. Going back to our intercepted post request, let's change the payload to the LDAP JNDI, our 10.0 IP, and we'll put in Tomcat since that is the server that's being used here. So here we had a few errors trying to get the connection started. So we're just going to go ahead and fumble with the payload here. All right, so after all that fun, we're actually able to get the reverse shell here. Let's go ahead and type in the payload, start the NC, LPP. As you can see, we've actually managed to get a reverse shell on the target. It's connected to the IP, and we ask, who am I? We are UniFi. Let's keep moving here. Next, we're going to be taking a look at post-exploitation. Now, I'm using this other note set here just because obviously I have a few different tabs open, so you got to use all the resources available sometimes. Sysinfo, let's see, command not found, all right. Once you have a reverse shell, you quickly find you aren't in operating as root. We've done some research and this seems to be the case outside of some of the fringe configurations. Start to ask ourselves, the MongoDB instance storing all apps aren't operating as root. We've done some research and this seems to be the case outside of some of the fringe configurations. Start to ask ourselves here, what can we do? Come to find out, MongoDB instance stores all application information on localhost without authentication. That means that once you have that shell access, you can read from and make modifications to the local MongoDB instance. I think you're seeing where we're going with this. We'll extract the password hashes for admin accounts and attempt to crack them. We'll reset the credentials for the admin user. We'll add our own shadow admin to provide access to the console. And then from there, you do whatever you please. Now, this is a really good write-up that I just really want to take time to point that out. Cracking the hash. First, let's dump the hashes from the local DB. Execute the following command using a reverse shell dump on JSON array of users, their privs, and most importantly, their hashes. So it looks like we have a little command here, or script for Mongo called to the port evaluation, like you said, of finding the DB for each print. Following the execution of this command, you'll be presented with something like the screenshot below. Okay. All right, the output reveals a user called admin. The credential hash is located in the X shadow variable, but in this instance, it cannot be cracked without any cracking utilities. Instead, we can change the X shadow credentials hash with our very own created hash in order to replace the admin's password and authenticate to the admin panel. To do this, we can use make password command utility. Let's do that now. All right. The S6S is the identifier for the hashing algorithm that is being used, which is SHA-512 in this case. Let's see here. All right, once we've generated the SHA-512 hash, the output will look similar to the one above. However, due to the salt hash, will change every time it's generated. Salt is added to the hashing process to force their uniqueness, increasing their complexity without increasing user requirements, and to mitigate password attacks like hash tables. Let's proceed to replacing the existing hash with the one we just created. Once we do that, we're going to verify the password has been updated in the MongoDB by running the same command we used before. And that will just call from the port and try to dump the DB again. Here we're going to have to install MongoDB, no problem. This has been a very tedious box here. Lost connection. I'm going to go ahead and get the shell back and start the process over. All right, we've been able to successfully connect here. We'll paste our script and update password in the MongoDB by executing this. After this, we're going to go ahead and go to the UniFi web portal and see if we can log in with our newfound or newly created credentials. Here we navigate to the web portal. Our old friend will use the credentials that we just created. And we have admin access to the UniFi network. Everything is great. Everything is excellent. All right, let's take a look at, here we can see maps, internet capacity, gateways, switches, ETC devices, if there was any. Now is a good time to go over the questions here. Start answering these. What is the function we use to enumerate users? db.get users. Once it accepts our answer, db.collection.find seems to be the answer here. Nope. Okay, let's try again. I don't even remember, but that's all right. We already gotten into the machine. All right, for each db.admin.find. Task 11, what is the function we use to update users when the database of MongoDB? We can check the hint, we can use Google, or you can remember like I did. What is the password for the root user? It's the one that's not crackable is the hint. Here it is. This is why we like save the notepad. Sometimes it's easier to do the lab than it is to correctly input the answer to these questions, which is, I have no idea. All right, submit user flag. And submit root flag. A lot of flags here. A lot of this can be found in the settings of the UniFi network webpage. All right, so the page shows the root password in plain text. Let's authenticate to the system over SSH. We use SSH root followed by the IP. type in the credentials. Alrighty. So we SSH in, ls, you can see root.txt is right there, cat the root, we get the flag. And that is UniFi pwned. Been a long lab. If there's anything you feel like I missed or could learn, feel free to like, subscribe, and comment. And thank you for watching.